Okay, in this video, we're talking slope. And we're going to go through this hopefully step by step. First, we're going to talk a short definition. Next, we're going to see what slope looks like from a graph. After that, we'll calculate slope. I mean, what happens if you don't have a graph and all you have are points? No one gives you a graph. Or what if the numbers are awkward? Lastly, we'll spend a moment seeing how slope describes how two quantities are related. How two quantities are related. When we've been discussing proportions, we've asked the question, are two quantities related? Slope allows us to describe how two things are related. Here we go. So one definition that you often see is that the slope of a line, that is the slope between any 2 points, is simply the vertical change over the horizontal change. This is often described as the rise over the run, rise being the up and down motion, run being the left and right motion. So here's a line, and I've already plotted what the points are, but the rise in green here is, here's my 2 points. The rise is the description of the up and down or vertical difference, which is if I come over here, it's going to be this point, and this, or this y value, and this y value here. So my rise is this distance here. Where my run, the motion, how far to go left and right, here's my 2 points. I look down this way, and I get my run from here. So my run is going to be this distance here. Here's my run. And this is my rise. So in this case, the rise is going to be 9 minus 3. That's the change. That's the vertical change. Where the run is this horizontal change. Again, from here to here, so that's 7 minus 4. So that's this description. So it's going to be this 9 minus 3, rise, over 7 minus 4, the run. And that brings us to the calculating part. So I have these 2 points. I have 7, 9, and I have 4, 3. There's my 2 points from the graph. And I'm going to, as a little notation device to help me keep things organized, I'm going to go from this point here, from the 9 to the 3. This is my vertical change. In class, we've written like this, the change in y. And then here's my horizontal change. It's my change in x. So if I fill in my calculation here, the vertical change is 9 minus 3 over 7 minus 4. 9 minus 3 is 6. 7 minus 4 is 3. That simplifies to 2 over 1. So we can say the slope is 2. But we want to remember it's broken up into 2 parts. That is the vertical change, 2, and the horizontal change. So for every 1 step in the x direction, the line moves 2 steps in the y direction. And if we go to the line, we can see this. Here's a point on the line. If I go 1 in the x direction, I go up 2, I'm back on the line. If I go over 1, I go up 2, I'm back on the line. If I go over 1 in the x direction, I go up 2 in the y direction, I'm back on the line. And so the slope is describing, again, the change in the up and down versus the change over the change in the left and right. So that's just slope looking at a graph, but with no units. So what does it look like when we actually include units? So here's an example. On a trip, you travel in 210 miles in 3 hours. After 5 hours, you have traveled 350 miles. So common direction is graph the data, draw a line, find the slope of the line, and then here is our last point in our description. What we want to do in the video is explain what the slope represents. So what is it telling us about the relationship? Well, this time we have two quantities. Unlike the previous video, we have miles. That's one thing we have. And we have time. So there's our two quantities. How are those things related? Let's make a quick table. So I'm going to put time on my x-axis. So this is going to be time. And time's measured in hours, where my other value, my other quantity, is miles. So that's a distance. All right? So I've got time and distance. Sorry, it's not enough room to write it out in detail. But I can see in 5 hours, or in 3 hours, I went 210 miles. So in 3 hours, I went 210 miles. And in 5 hours, I went 350 miles. So I'm going to plot time, or the hours, on my x-axis, where this is going to be my distance in miles on my y-axis. And I have 2 points I can plot here. I can plot 210. Now, I don't have 210 exactly to graph, but I know it's going to be below 250 and above 200. So it's going to be closer to 200. So I'll put it about there. And then 350. Now that I can easily plot. So 350. And with this, I can draw a line. So I've plotted 2 points. I'm going to draw a line here. And I get something that looks like this. So we've graphed the data and we've drawn a line. Now I need to find the slope. Remember, the slope is the vertical change over the horizontal change, or the rise over the run. So I can see here is my rise. And when I look, it's a little hard to see what that is on the graph because I don't really have an exact spot on the graph I can line up. With the run, now that's a little easier to see because I can see it goes from this line to this line, which is between 5 and 3, which is why we want to calculate it. Because we can't always see what a value on the plot is exactly. I mean, granted, we're given it this time. That's why we want to calculate it. So if I come down here and I plot the points, so I have 210 is one plot, is 1 point, I should say. And 5 and 350 is my other point. Since I want to have my subtracting the large minus the small, I'm going to draw myself a line here. And this is going to be my change in y. It's the change this way from 350 to 210. So that's my change, 350 minus 210. And x, my change in x, is going to be 5 minus 3. So let's write that out. So I have 350 minus 210. And on the run, I have 5 minus 3. And let's remind ourselves that this 350 minus 210 means miles. You know, the first example, there was no quantities, there was no units. But now these numbers mean something. These numbers mean miles, or these numbers mean hours. So 350 minus 210 is 140. 5 minus 3 is 2. And if I simplify 140 over 2, I'm going to get 70 over 1, or 70 miles per hour. 70 miles per hour. See, now these are now I have units, so the numbers actually have some meaning. So 70 miles per hour. So the slope, this is our slope, what we calculated. What does it represent? Well, when I go miles per hour, aren't I describing how fast I'm going? So the slope represents how fast, that is my speed, how fast I'm traveling. Or I suppose you're traveling, if I'm using the language correctly, how fast I'm traveling. And I'm traveling 70 miles per hour. So what does the slope represent? It represents how fast I'm traveling. So this tilted line is describing the speed at which I'm traveling on this trip, which contrasts a little bit from our first example where there was no units. Sure, what it's still saying is I travel over 1 unit and up 2 when we have this slope of 2. In this case, we have a slope of 70. For every 1 hour every 1 hour travel, I travel 70 miles. For every 1 hour I travel 70 miles. I do hope this helps. Let us remind ourselves of what we just did. We did a quick definition of slope, which was the change in y, that's the vertical change, over the change in x. Right, so that's looking this direction on the graph versus this direction on the graph. We found the slope of a graph, looking at a graph. That's where we see the change in y over the change in x. Then we calculated the slope. What if we didn't have a graph? When we calculated the slope, remember we wrote out this way, and I was very deliberate to go from one point in both of them to the other point. And lastly, we talked about how the slope describes two quantities. In our second example here, it describes how the miles and the hours are related to each other. So, and how are they related? It's telling me how fast I'm going. Well, I do hope this helps. This is me signing off.